All right. Hey, everybody. Sorry, I was having mic issues. So we're back for part three, putting together a relay computer. So let's do our typical throw this guy down, erase part two, and we'll just bumper to three. Whoa, that was a horrible three. Goodness. Part three. There we go. A little better. All right. So for those who might be new here, we've been building a relay computer that uses relays, kind of as the processor, logic processing gates and things like that. So this is it. So far we've just been working on the resistors. There's over like 580 something parts. That's probably in the neighborhood of like 3,000 solder points that we got to make individual. So we have, I think, on the menu tonight, we have, I have a set of 220 ohms resistors, 22, 33. Still got seven different types of resistors I need to solder on, and then we'll move on to diodes, which that includes the LED diodes and everything. So I guess just a quick recap too. This soldering board, this relay computer, it's designed by a guy named Joseph Allen. He's got his own YouTube. Let's see if we can bring it up real quick. Give me one sec. There we go. So this is what it's supposed to look like once we have this all the way together. Up at the top, um, that's all. These are all the relays. He has it designed, all the logic gates and everything. If, ors, else, whatever you want to call them. But the neat thing about this is the sound it makes. That clickety clack. Each click and clack, that's a cycle um, that has been run, and in computation that's been run. And it's going to be neat to see that once we get this going. So it's kind of just a slow going. We're just assembling this. Like always, I'll probably be just playing music, not talking much, just assembling this computer. This time we'll try some different music. We'll don't know if it's gonna be good, don't know if it's gonna be bad, but we'll go for it. So here, let me get that going, and we'll come back to the workstation. Oh, kind of a funny thing. So I put these guys in the oven, and I wasn't thinking, or I didn't know. Now I do. But certain metals that are made magnetic can be demagnetized if they reach a certain temperature. So now they're not magnetic at all. So I don't know if I'm gonna be able to use them. We'll try. But hey, that's this whole board's kind of been a learning process. That's what we're here for, right? Just to learn. Get that set up. I think. Let's see here. What do we have on the instructions? Let's go back to that. So last time we stopped at, I think, the 100 ohm resistors. Yeah, that looks about right, because yeah, we have some, these are it right here, 100 ohmer down there, and then all down here. So next up is our 220 ohm resistors, and it looks like we'll be working in this bottom part of the board. So I guess let's get going. Find my 220 ohms. I believe that's it. Yeah, yep, that says 220. Alright. So according to the instructions, it's going to be resistor 143, 444, 150, and then looks like 2 over here. That's all I see. Alright, let's go. Here, actually, yeah, I'm going to skip this song. There we go. So for anyone new here and who just doesn't know electronics, if you're wondering what the heck a resistor is, oh yeah, see, they're not magnetized, so we can't use them. But yeah, if you're wondering what a resistor is, hey, maybe I can do it this way. A resistor kind of does what the name says. It resists the flow of electricity. So like these resistors up here, they lower the voltage because they're resisting the flow of electricity, so we don't overload the LED or the light emitting diode. I just noticed my HDMI, my scope's not working. There we go. Yep. Alright, let's get this set up. So sometimes we do have to be careful because I'm just double checking, because we have, I don't know if this will show up, yeah, 220 ohm resistors, but the instructions also do call for a 220k ohm. So I'm not doing my math right, but maybe 100,000 more. Let's go back to the instructions. Let's just double check before we start soldering. All right, 220. There's no K after that. We're doing all right. Doing all right. So if there is anyone out there, anyone in the chat, I probably won't see it. I don't have a chat window up. So just feel free to chill out, play along, whatever. But we're glad you're here. But man, for 584 parts, it's a lot. It's tedious. 149 looks like resistor 150 is out of the frame. But it looks like 151's in it. So we'll do two. Well, we'll do 2 resistors out of the frame. You all are okay with that? I guess you can see it in the main camera. The biggest ones we had to do were all these 1000 1K resistors. It seemed like it took forever. I think I only made it through in the first video two sets of resistors on that one. Or that might have been my only setup, to be honest. There was 50 something, 50, 60 some odd. Alright, so resistor 151. There you go, sir. There we go. Alright, cool. Now let's flip it over. Start soldering. Whoop. Oh, you know what? Before that, I forgot a step. I need to put some Kapton tape down on it to hold these guys down. I want it to look nice before we solder it down.
trouble is Christmas. I just don't understand it. Instead of feeling happy, I feel sort of let down. I know how you feel about
I am trying new music with this, just kind of chill. I guess this is a Christmas song. Charlie Brown Christmas. We have, how many days do we have for Christmas? 330? 31 days? It's February tomorrow. I think that's it. My demagnetized standoffs. Kind of a bummer.
What is it you want?
But get rid of this plate because it ain't doing us any good. Oh no, I think they do have Christmas music in this playlist. That's unfortunate. Should have checked it before, huh? Ah, you know what? Snow day. Whatever. Nah, I'll change it. I'll change it. Yeah, I don't know. I don't know if this is vibing or not. Sorry, guys. But it's whatever. Let's get to soldering. I don't know about y'all. I'll have a steady hand in that. There we go. There's the 220 resistors out of the way. Put them back in their little baggie. I know what they are. So you can tell, for those who don't know, these little color bands is how you tell what resistors they are. I can't do it off the top of my head, but I do know the last band, the gold band, is for the accuracy of it. So plus minus 5%. So this resistor could be a 210 ohm, and that would still be within spec. In fact, you know what? We can test that. Let's break up the multimeter. Just for fun, why not? Don't got anything else going. Switch that to ohms. It better be 220s. So we do that. And there you go, 216. So that's pretty close to 220. Pretty cool how that works, huh? So next on our list is, I believe, let's go back over to Firefox. 22 ohm resistors. We're gonna fill all that up. Nice. All right, let's look for that. That's the 220K, so we gotta be careful. There they are. Got them to the side. Pop back over. Cool. All right. No, I'm gonna wait to cut those off because it looks like we're gonna be working right there according to the instructions. And then there's one lone one all the way over there. So, all right, let's go. Been facing everything. The gold band is usually to the right if it's a horizontal resistor. If they're vertical, I've been facing the gold band up. So it looks like we're still, following the trend. Oh yeah, so this one right here, if you see in the bottom left corner, there's two vias. And we probably wouldn't want to put it in this via right here because that's going to something else. That's a through hole. We want to use these two holes right here. We gotta be careful. And also the same down here. You don't want to use that hole. That's for diode. I think that's why that's supposed to go there. I could be wrong. Probably am, but that's okay. So we're going to populate this whole road. And then there's one lone one resistor number 192, I believe. Yep, 192. I'm going to go ahead and populate that guy. He's He's a little off frame, y'all won't be able to see it. That's okay though. Furthest resistor on the bottom and to the left. The corner resistor. Alright, everything's looking pretty symmetrical, pretty straight, pretty good. Except for that guy, I didn't do. You know what? It don't matter. The electrons don't care, the angry pixies don't care which one, if it looks bad. Looks good enough. So I imagine once we get this guy together, one of the different parts of the video or the stream I'm gonna stream this live when I first power it on. That's gonna be a little scary. Hopefully it doesn't let the magic smoke out live on air, but I think we're doing good so far though. I'm pretty confident. So that'll be, if y'all get to see the magic smoke, I guess we'll troubleshoot it and see what happened. But I'm feeling good about it. We probably won't. He does have some testing tips. You apply the voltage before you add in a lot of the IC, the integrated circuits. So you don't damage those. So if you can test the continuity in certain parts of the board. I haven't gotten there yet, but if things look good, then you can add the circuits, and if that looks good, then we can add the relays. The cool thing about the relays is, which here am I gonna sleep on? So the relays, they do come in a sleeve. Looks like this. They all do go here, and we're not going to solder the relays directly because we have little sockets. That's where they're going to. So that's going to help us if we run out a relay that was recommended. So. But the relays up here, I'm probably being a little repetitive, but that's what creates all the logic gates. This is basically an expanded view of a CPU, I guess. And then these lights that we're going to put right here tells us that we're writing data over here to these registers. And these are a bit, so we have 8-bit registers. To what address and stuff, oh yeah, no, it's down here, the addresses and stuff. So we have 8-bit registers and 8 addresses in address A, and then 8-bit addresses in address B. It'll be cool. This is about as low level as you get. Programming and stuff. This uses from what it looks like this probably isn't right, but assembly programmer. So it's just pretty neat that Joseph Allen, this guy named Joseph Allen, was able to create this. So you should go check out his YouTube channel if you want to see a working copy. And I think he still sells these boards too. I'm not affiliated or anything. I'm just doing this for fun. Make the same joke I made in the last video, kind of like Saitama from One Punch Man. He's a hero for fun. I'm an electronic enthusiast for fun. Oh my gosh, I can't get solder in there. Come on. You can do it. Ah, there we go. Oh, you know, one thing I probably should do, I need to get some rubbing alcohol. I'll probably do this off video. I need to clean all these solder points, because the solder is resin cord solder, and it has a thing called resin, which is, or flux, I'm sorry, which is pretty much this stuff here, although this is no clean flux, but if you leave flux on the board, it can do bad things. So it's always good to clean. But ultimately, you know, I'm just doing this for fun. I'm not looking to go big time streaming. Hey, I'm learning. I want to share it. And yeah, who knows? Who knows? And everything I say probably might not be right. But as long as we're in the right ballpark, right? Cut off all these ones. Man, these make a mess too. I have a whole stack of them from all the other resistors. Okay, so that does it for the what ohms are we on? What did I say, 22 ohm? I can't remember now. Yeah, the 22 ohm resistors. Alright, so we're cooking along. So next in our pile of resistors, 33 ohms. We got 5 of them, looks like. Yeah, so they're gonna go right here. Get that lined up on the scope. Cool. Yeah, I can show you all the instructions too. So blurry. So yeah, 33 ohm. Right there. So yeah, we're in the right spot. I think these are it. Yeah. So 33 ohm. So if anyone's out there wondering, like, how is this a computer? Because you know you're looking at your laptop or your phone, or your desktop that's sitting there on your desk or the floor, wherever it may be sitting. This is a very primitive computer. Kind of think back to the vacuum tube days of computing. It'd be interesting to see, you know how they always make the comparison to the Apollo lander, like your calculator has more power than the Apollo lander. I probably should have researched this before this video, but it'd be cool to see if, like, hey, does this compare to that? Is it anywhere in the ballpark, or is it faster? Because it does have some faster, more modern IC integrated circuits on it. Like for example, these memory chips, in comparison to like the Apollo computers that are on the Apollo rocket, they use something called, I think, rope core. Don't quote me on this, but it's rope core memory, something like that. Where it's like two pieces of wire that cross, and hold on, actually, I might have something that could represent it. So totally not to scale, totally not to size, but they would basically have an array of, it would basically sew in the program, but they would have these little metal, they look like discs, and they would cross the wires through it, sew in, and based on the address, each wire had an address in the array, so this could be like address 3B or something. And depending on how it's magnetized, these wires would read the polarity of the magnet, and that would either be a 1 or a 0. And so a whole string of these together would create what we know as the program. It would string together a whole bunch of 1s and 0s. But this is kind of basically what we're doing here too, but it's not rope core memory. So I'm curious if, maybe if this is faster than the computer on the Apollo moon rocket. Definitely a lot smaller, that is for sure. Even the one that was on the lunar lander. Yeah, maybe that's what I do on these streams. I just bring up like a little history tidbits like that and show them on screen. But I don't know, we might not get any soldering done if we do that. For those of you who are watching this later off stream, this is the third part to it. So we got a little ways to go. We're just working on resistors right now, so kind of not that interesting. But hey, if y'all just want to put this on in the background, great. It'd be cool, chill background stuff. So all right, we got these 33 ohm resistors, and let's tape them down so they don't come loose. Let's solder them in. Cool. All right. Flip it over. Let's go. Okay. Yeah, it looks pretty good to me. Cut these down to size. Ciao. Whoop, I messed up. Cool. Alrighty. Moving right along. We're 30 minutes in, not bad. Not too bad. Alright, next We got the 220K resistors. Let's see where are these supposed to go? Bring up the instructions. Yeah, so the 220Ks. Oh, we only got two of them. We only have two of them. Right, 197 and 193. Sweet. All right, cool. Man, I almost think we might get through all the resistors. Yeah, we only have 4 more sets left. All right, righteous. All right, there, cool. Got that in frame. Oops, didn't mean to minimize that. Sorry, guys. The screen just went black. There we go. Cool. Now we gotta find them in our stat. There they are. The two 220Ks. Just means they're more resistive, you know. Resistive to the current. Alright, which ones are these going in again? 193, 197? 193, 197. Alright. Go to the side. To the right, I mean. You know what? I might go ahead and hop to the next set. Take these down. And since there's just not that many, there's no point in flipping it over to solder. So we got those two in. Looks like someone did comment. I said I wasn't reading comments, but I see one that popped up on the screen. Someone says they love Christmas. I think I know this person too. They're pretty cool. They're pretty cool. Probably the best person in the world. Alright, so next resistor 2.7. Show y'all what I'm doing. Alright, so the 2.7K resistors, there's only one. And that's resistor 194. Yep. Alright, you know what? Let's go ahead. What's our 18K resistors? Since that's only one, there's no sense in hopping back and forth. Alright, let's do the 18K and the 220K. So we got 18. Let's do the 2.7K first. So the 2.7s are gonna go. Where did I say that's gonna go? That's gonna go down all the way down here, and then the other guys just do one at a time. Alright, 2.7. Donde? Here, there. Wow, I only ordered the exact number. Oh no, I ordered one extra. So, does that say 2.7? Yeah, it does. These are blue. Okay, they're a little different. Wonder if that means anything. Any of you electronic guys know? Won't pretend to know. Alright, cool. And this doesn't have a gold band either, it has a brown band. Oh, let's read this. Oh, this is a more this is 1% accuracy, so this is more accurate. Let's try that. Let's test it. Oh, you totally cannot see that. Maybe do it this way. Oh. Here, I'll move the screen. You'll see it. Oh, worry not. Oop. Oh, you know what I can do? I'll just set this pin number. There you go. Alright, so right here, 2.6. Alright, yeah, it's almost right on the money. If you round that 9 to the 6, that'd be 2.7K. And you see that little K, it's hard to see on the screen, but it'd be right there. Huh, the more you know. How about that? Maybe blue, there's more accurate ones if you need tolerances and stuff. And that would make sense. Some of these chips, like you have pull down resistors and stuff, or you want something tighter tolerances. And you can't have that much variance in voltage or resistance, so makes sense. Alright, so there's our 2.7K fancy, more accurate resistor. And our next one was, what did we say, 18K. Where did I put those? Those are 0 ohm. 18K. Ooh, these are more accurate too. Alright, we got 2 of these. These are gonna go, looks like, I gotta pull this captain tape off. I'll reposition it actually. Oh, you know what? Can't take those guys down yet. Because these were the ones we started with, and we got that. Then one goes right there at 195, I believe, and the other one goes at 198, which is right there. I think the more accurate ones, they would use a different color than a brown band. I think it'd be like gold or platinum or something. Okay, there's 18K. Okay, our next ones are 3.9K. Are they still in this corner? They are. And it's just 1, 2. Let me show you. Oops. Come on. There you go. So we put that guy in, the 18Ks right there and there. Boom, boom. 3.9K resistor. You are going to go right below 2.7. Oh, that's just out of focus. Okay. Yeah, since that's just one, let's keep doing what we're doing. Just populate all these down in this bottom left-hand corner. 33K. I'm forgetting the ohmage. 3.9. Here they are. Oh, these are cool. They have a little orange band, white band. So maybe they might have gave us Mauser. They might have either I ordered them. They didn't have the typical ones in stock. And I ordered some nicer ones, or these are all they had, and so that's what they shipped. Who knows? But there we go. These are 3.9K resistors. Next we have 33K resistors. Ooh, they're all on this left side, but I think they're resistors. The last ones, they're called 0Ks. They're basically just a shunt of a solid piece of wire that's going to go in 199 down there. Yeah, they're just that. It's just, honestly, you could just use this and it would be fine. There's no resistance in that one, but let's go ahead and populate. Here, I'll move this over for everybody. I just gotta remember to come back over here and populate these guys. So 33Ks. These are not the fancy ones. They're tolerance of 5%, but that's okay because they have all orange bands for those who like the color orange. Yeah, I'm not gonna bother with the microscope on this guy. Well, I didn't think I'd get through these resistors that fast. I might have time for some diodes. I believe that's next in the instructions. I think this is it for resistors. I think in one of the videos I was getting, I was mixing up my words. I was saying relay when I was supposed to be saying resistor, and resistor when I was supposed to be saying relay. There's probably someone out there that watches like, what's this guy talking about? You know what, sometimes I don't know, sir. Or I knew what I was talking about, I was saying the wrong thing. That's okay. We knew where we were going, we were just saying the wrong thing. Alright, cool. That does it for the 33K resistors. Now, the 0 ohm resistors. I'm curious. We'll put that on the meter. Like, what does the meter gonna say? Is it could we have just like honestly used something like that? You know, put that right there. Won't look as cool. We want this to look cool, right? What if, you know, I don't think it has enough. It'd be insanely hard to program, but what if we program this to control, because this has outputs at the top. I don't think it would work necessarily, but control some LED lights. Maybe just the simple ones where, you know, not the RGB. They're RGB, but they don't do all the cool fancy stuff. It's just it sends out a setting, a power level. Which way do we want to do this? Oh yeah, you know what? I said I was gonna put this on the meter. Let's see what happens. Sidetrack. So we should see, yeah, no resistance at all, 0, totally. Should be the same as that, same as just touching the 2 leads together. Yep, well, that's kind of cool. I didn't know these were a thing. I kind of don't see the point, but maybe there's a reason for it. I don't know. Like I said, I'm just doing this for fun. I don't know everything. piece of tape? Nah. Just do two pieces. Alright, that does it for the resistors, and now I need to look for, I think there's some diodes that we're going to do. I'm pretty sure we start filling in these LEDs. Technically, LEDs are a diode. They're called a light emitting diode. Electrons can only flow, usually, can only flow one way through an LED. So we gotta work on getting our polarity right. But I don't know. We'll see how much time we got. Do this for a little bit longer. At about 30 minutes, maybe. Cool. Oh, that wasn't a good tape job. That's okay. It works. Good enough. Alright. Start soldering. Alright, I'm excited. We're moving on to different components. There's 3 videos of resistors. Kind of boring. Oh. Soldering iron was asleep. No? There you go. There it goes. I just had a random thought too. I wonder if you can measure it, but do resistors also resist? Would they resist heat? I don't know. Come on. Ah, there we go. Make sure that still sticks. Cool. Alright, that does that side. Now we gotta move it over here. 33 ohms. I think I got everybody besides these over here. Yeah, this might go pretty quick. I don't, well, to get to the relays, like I'm not sure, you don't have to, I don't think, solder all the pins in, but might be a good thing to do. Or that'd just be a waste of time. Because it only uses 8 out of the 16 pins. I just was looking at comments and someone was here that knew. They probably could tell me, but yeah, whatevs. Oop, cut that a little too close to the board. Alright, let's clean up. We'll see what's next in the instructions, see what we want to do. Oh, you know what? I missed a guy over here. Alright, we're checking our work. Missed a pin. There we go. Miss anyone else? Yeah, we did. Alright, there we go. Oh, oh. One more. Uno más. Got it. Alright. So diodes, as the instructions say, here, let me show you on screen. What are diodes? Did all those, did these over here, resistors, our R0 resistor. Alright, diodes are polarized. They must be inserted in the proper orientation, which is here. So our diodes, I need to find those. Oh man. Alright, let me see if I can go find those. I'll be right back. So I got the big box of all the parts. I don't know if that's coming out on camera. I don't have it up on screen, but lots of parts. So I'm seeing some rectifiers, some capacitors, capacitors. These are our transistors. There's our diodes. Okay, I found some bidirectional diodes that we're going to use later. Fixed terminal blocks overfill at the top. Some more solid state capacitors. Unshrouded heat. Oh, these are our headers. Unshrouded headers. Ignition driver. I don't know what that's for. Amber diffuse. So, ooh, I went with amber lights. I thought I went with more red. Maybe not. Some other IC. There's the little screens. They're gonna be going right there later, or soon actually. Power jack. Oh no, everybody. I don't know. Scotch key diode rectifiers. I don't think these are it. They put them in, let's see what they are though. I chose 2 of them. That almost looks like it. Let's take a closer look. It's showing 3. Iron. I'm gonna set these. Transistors. More transistors. Holy moly. I don't know. Now I'm thinking, are these it? don't think these are it. SA SB230s. Diode goes there. No, nah, the SA, okay, so that's for 3.3.1. Well, there you go. Maybe, I don't think I took them out. I'm wondering, did I get these diodes from DigiKey? I can't remember now. Yeah, shoot. Sorry, everybody. Not finding the diodes. Let's check the DigiKey box real quick, just in case. Double check up here. Maybe I put it up there. I just didn't realize it. We're looking for 1 in 4 twos. Those capacitors. Now that more capacitors. More terminal blocks. Oh, they're right here. You know what? I goofed. Alright, found them. Alright, everybody, we're back in business. Let's go, let's go, let's go. Alright. Alright, so part number is 1 November 4002. We got a 1 November 4002-G. Means it's special. Alright, does it show up there? Yeah. Yep. Alright. Okay, so these diodes are gonna go, they're supposed to go right there. There's 3 of them and they're polarized, meaning the electricity can only flow one direction. I gotta get a polarization correct. There should be like a little white tip on one of them. I believe that's, yep. So if y'all see these guys, that's how they are supposed to go. Positive, negative. I think that's the negative side, the top side. Or I could be getting that backwards, I don't know. Man, these are thick too. These have thick leads on them. Jeez. So I gotta get these kind of exact. Yeah. Switch that to up here. Oh hey, I just noticed. Joe Allen. He's got his name on the top. For those who might have just popped in, Joe Allen, he's the guy who designed this board. So go give his YouTube a look at. It's in the description. If you want to hear the relay computer go clickety clack. No, I didn't get that guy. Done very well. It's looking good. So in some cases, diodes, they can be used to protect the circuit. So if you get something backwards, or some electricity where it's not supposed to be, these will prevent the flow. So I'd imagine, I think he explains it, it's either these or there's some that protect, like when these relays are like really getting after it. There could be the term's leaving me, but like a surge in electricity or something like that. That will that could cause problems. Overvolt, or it just builds up the capacitance, I guess, or something like that. Okay, so I got these three. I think I'm gonna move on to the next set of diodes, which are the SB230PAs. These are SA113CAs. These are not the diodes you are looking for. SR203s. I think we're gonna skip that guy. Because I gotta look back at my notes. There's a reason. I think one of the diodes. Okay. Yeah, let's skip those. Let's go ahead and go to the SA113CAs. These are the. I'll pull that up on the. So I'm gonna skip this guy. It's just a singular one. I don't know. I think I might. He's somewhere. Oh, hold on. Let me Control F. SR203. You know what? I bet you this guy does go down there. Yeah, you know what? We'll go ahead. Why not? Yeah, there's, if I remember right, I had to substitute part, but this one actually worked for us. Sorry, 203. Okay, and this one's polarized. All right. So sometimes, like, they'll discontinue parts, and I think this was I believe, I'm gonna say this was a replacement. Or you know what? Maybe I made a mistake in ordering these. I think we're okay now. I'll go back check my notes. If not, next video you'll hear about it. Or this whole thing goes up in smoke. And then we just try again. Okay, there's those. Yeah, it's still sticky enough. We'll use this Captain tape. There's that. There's these guys. So yeah, next are these transient diodes. They're suppression diodes that kind of keep voltage in check. What I was trying to say earlier. But we got a bunch of these. See how many we can get done. Yeah, these are going to be all at the top. But let's go ahead and solder these bad boys in. Come out of ways. Cool. So there's 3. Get this big boy down here. All right. Now I'll start with the suppression diodes. There we go. Instructions highlighted. Alright, makes progress tonight. Alright, so these, it doesn't matter which direction. So if you notice, like these, the other diodes, they had like a little white tip. It doesn't matter which direction these go. They're bi-directional. So check them instructions. Yeah. Yeah, so these do have thicker leads. It's gonna be hard to make this look nice. I need a tool. There's a certain tool out there that allows you to bend these kind of like perfectly, so it'll be centered, but that's okay. Cool. So these probably do suppress the capacitant voltage that will come off these resistors. Capacitant meaning kind of like a capacitor, you know, that energy just builds up in the system. That would be bad. That'd be bad in K. You know what? Now I'm wondering, did we miss a resistor right there? I have to go back and look. Resistor 189. Might have made a mistake. Yeah, let's go ahead and check. No matches were found. No, I don't think we'd miss it. Weird. Or it might be later in the instructions. Yeah, we'll go back and do it off video. These are hard to get on there. Okay, you're good, you're good. I'm gonna break the board if I don't do this right. Alright, Mr. Diode. Cool. You know what? I'm gonna flip. It's gonna bug me. Flip this guy around. Yeah, I feel like I might have missed that resistor. Maybe it's somewhere in the instructions. Maybe it's just the extra one he had. It's bugging me now. I can't stop thinking about it. Oh, I'll fix it. Okay, so that does that row. I think we have 1.5 more rows for these guys. Moving along. Move the scope. So if you notice, a lot of these guys, this points out what the relay does. So like that speed count relay, it's all the kind of names of the logic gates. I believe, I think, pretty sure. So we'll know which one is which. It would have been cool to get these relays that would light up, because then the whole thing would just. Maybe we could power wire in something. Have a little fun with it. Although I don't know how much power that would draw. It would change the operating parameters of this board. didn't go in there very well. This would be helpful if I did have the right tool. Maybe I should get it. Come on, Mr. Diode. Don't fight us tonight. It's a Friday night. You could fight Saturday if you want, because Saturday's alright for fighting. Guess with these random thought, but I wonder if these would be called no, not shunt diodes. Maybe not up to date on the terminology for these guys. I just know they're diodes. Here, so we got all those. I don't know if I'm gonna be able to. Whoop. So I can knock the main camera. Well, I don't think I can get this scope then. Unless if I. Let's just move the board. So we got. I think we have one more left on this. This row, and then there's a whole row down here we gotta get. Kind of in the zone now. That song got me in the zone. Enough. Flip you around. Had you upside down. Not that it matters. Just for synchronous. Come on, guy. Oh, Mr. Diode, why? There you go. Down in there. Alright, last diode. working on straightening some of these up. Alright, let's go. Let's tape them down. I think I have a different roller cap to put that'll work better for these guys. Or I might not. I don't know where it's at. Yep, nope, found it. Sweet! Alright. Last row. I think I can already use that for that. Alright, getting ready to solder. Last solder of the night. Takes a minute to heat these guys up. There it goes. More solder at this one. There we go. double check because I was not missing down on these guys in the middle. Make sure things still look good. Yeah, I pushed one out. Cool, let's go for it. Alright, looking good so far. Let's see, give y'all a close-up view. Alright, we did good for tonight. We got some diodes in. Might do the LEDs next time, I think. But yeah, we did good. So that's that. Probably cut those off camera in the stream here. So yeah, we're making progress. We populated some of the diodes. I think we have a few more to go. I'm gonna see if I missed that guy. I don't know. I couldn't find any instructions, but we're making our way. Before you know it, we'll be populating the push buttons, the screens. This thing's coming together. A long far cry from what it looked like before. I gotta do a before and after image. I'll probably do that next time. Oops, I did push that guy out a little bit. Well, you know what? That's just how it's gonna be. All right. Well, if you're still here, thank you. Thank you for stopping by. We'll be on part 4. Maybe by part 6 we'll start testing things. But we're making some headway. So I appreciate you. We'll see y'all next time.